Hi. In this set of lectures, we're talking about mechanism design. When we think about designing mechanisms, in effect what we're doing is we're designing incentive structures so that we get the sort of outcomes we want. Now, to get those outcomes, often what we're trying to do is we're trying to induce people to take the right types of effort. So, for example, if I'm an employer, what I'd like to do is I'd like to write a contract so that people actually put forth a lot of effort in their work as opposed to slacking off. Alternatively, if I'm auctioning something off, what I'd like people to do is reveal their information. I'd like them to reveal how much they value something. So another feature that we want when we construct mechanisms is revelation of information. So when I think about mechanism design, two of the core problems are dealing with these hidden actions and dealing with hidden information. So how do we write mechanisms or incentive structures that overcome those two problems? That's what we're going to talk about in this lecture in a really abstract way. So let's start out by talking about hidden action. Again, what do I mean? What I mean is this, is you're an employer, and let's suppose you hire people who make pots, so they throw pots. And these people can put forth effort. They can put forth a lot of effort, or they can sort of slack off and not put forth much effort at all. What we'd like them to do is put forth a lot of effort. But I can't tell. The only way I could tell is if I sat there and monitored them all the time, which would be really, really costly. So instead what I'd like to do is I'd like to write some sort of contract so that they always put forth the right amount of effort. Now, sometimes these are called moral hazard problems. And the reason is this, is that because I'm not being watched, if I'm the employee, I'm sort of have some moral hazard. I could cheat, I could slack off. And so the question is, how do people write contracts to overcome these moral hazard problems? So let's write down a simple model and see sort of how it works. So let's suppose I've got some workers, and these workers can take some effort. They can take an effort level 0 or an effort level 1. And again, that's not going to be observed. What is going to be observed is the outcome. I'm going to see whether the pot is good or whether the pot that they made is bad, whether it's floppy. So I don't know whether it's going to be a good outcome or bad outcome. But I do know this. I know that if they're diligent and they put forth an effort of 1, the probability that the output is good is 1. It's for sure going to be good. But I also know if they slack off, there's some probability, P, that it's still going to work, that they're going to get a functional clay pot. What I'd like to do is I want to induce this effort level of 1. But how do I do it? The reason it's hard to do is because it's costly to put forward that effort. So a worker is going to pay this cost C of working hard, and they'd rather not. They'd rather slack off. So what I want to do is I want to write a contract so they put forth the right level of effort. Well, how do I do it? Well, it turns out it's not very complicated. What I want to do is I want a contract that says, I'll pay you M, I'll give you M dollars if it's good, and I'll pay you nothing if it's bad. Here's the core idea. The idea is I want what's known as incentive compatibility. Incentive compatibility means that it makes sense for the worker to put in the effort. So I want to give them amount of money M so that everybody's going to put forward the effort. So how do I figure that out? Well, it's a very simple model. What's their payoff if they put forward the effort? Well, it's M, because they're going to get the money M because the outcome is going to be good for sure. But then it's going to be minus C because they're going to pay the cost C. What's their payout if they don't put forward the effort? Well, it's going to be P times M. Because with probability P, they're actually still going to get a good outcome. And so they're going to get P times M, which is the payoff for getting a good outcome. So the incentive compatibility constraint, which is the idea that it makes more sense for them to work hard, means that M minus C has got to be bigger than P M. And if I manipulate things around, I get the following inequality, that I've got to pay them at least C over 1 minus P. So this is the solution. If I want to induce people to work hard, the amount of money I've got to pay them for a good clay pot is going to be the cost of effort divided by 1 minus the probability that if they were lazy, they got a good outcome anyway. Okay, very straightforward. Now remember when we do models, sometimes we get stuff for free. Well, here we're going to get something for free as well. These are sometimes called comparative statics. So what I mean by comparative statics is here's my equilibrium level of payment. This is what I should pay people to make a good clay pot. Well, what this tells me is how that varies as I change other variables. So for example, what happens if the cost of effort goes up? Well, if C goes up, then C over 1 minus P is going to go up, which means that M has to go up. But that makes sense. If it's costlier to put forward high effort, then I'm going to have to pay people more money in order for making a good pot, to induce them to work hard. What about P? Well, this is complicated. P is the probability that someone who slacks off still gets a good pot. Well, if P goes up, that means that if P goes up, that means 1 minus P goes down, but it means 1 over 1 minus p goes up, so it means that m goes up. So what we get here is that if the probability someone gets a good clay pot anyway increases, I also have to pay people more. And the reason why is because if they think about it, there's more incentive to slack off because there's a higher probability I'm going to get a good outcome anyway. So what we get, these comparative statics, are that m is increasing both in the cost of effort and in the probability of getting a good outcome even if you're not putting forward the effort. So we get these nice sort of comparative statics results. Here's maybe the most interesting thing about this whole model. We now know what the action is. So even though I called this a hidden action problem, if m is bigger than c over 1 minus p, I know what the action is. I know the effort is 1 because it makes sense for people to put forward high effort. So I've taken a situation where I had hidden action, and now I know the action. However, it cost me. How much did it cost me? M. How big is m? C over 1 minus p. Let's now go to hidden information. What is hidden information? Well, let's suppose you're an insurance provider and you don't know whether someone's a safe driver or risky driver. And what you'd like to do is not get risky drivers and only get safe drivers, or alternatively, you'd like to have risky drivers pay more for their insurance. Or let's suppose you're an employer and there's two types of workers. There's people who have really high ability and there's people who are low ability. What you'd like to do is you'd only like to hire the high ability workers. So let's work through that scenario. Let's suppose there's two types of workers. There's these high ability workers and there's low ability workers. And you don't know which is which. You can look at their resumes, but it's hard to tell. But suppose you know the following is true. Suppose you know that the cost for these people to work, for high ability workers, it's fairly low cost to put forward an hour of effort. But for low ability workers, it's higher cost to put forth an hour of effort. So what you can do is you can say, okay, you can come to work for me and I'll pay you some amount M. So suppose there's a fixed wage that you have to pay people. There's a minimum wage. What you can say is, but before you come work for me, what I want you to do is, work a couple hours in the kitchen for me and, work a couple hours on this project for me just to see how well you do. Well, let's think about the incentives for these two types of workers. Let's let K be the number of hours I want to make these people work. If you're a high ability worker, the cost of working K hours is just K times little c. And you're going to be willing to do that. You're going to be willing to put in these hours as long as K times little c is less than M, the amount of money you're going to get paid. But if you're a low ability worker, if you choose M so that it's less than K times big C, you're not going to do it because your cost, K times big C, is going to be higher than the benefit, which is M. So what you'd like to do, in a way, is to say the number of hours is just equal to M over big C, because it's maybe plus some maybe a little bit here. That way the low ability workers won't take the job, but the high ability workers will. So what you're doing is even though the information is hidden, you don't know whether someone's low ability or high ability, this will separate them out. Let's do comparative statics on this. How does the number of hours depend on M and on C? Well, as M gets bigger, K is going to get bigger. But that makes sense. If the job pays more, you're going to have to make people work more hours. What about with respect to big C? Well, as C goes up, K is going to fall. This makes sense as well, because if the cost for these low ability workers goes up, then you're not going to have to make them work as many hours to induce them to just say, look, I'm not going to do it. It's not worth it. Now, these are sometimes called costly signaling models. The reason why is this, is that the high ability workers had to signal by working K hours that they're really high ability. Let's go back to this contract. I've set K so that the high ability workers are willing to work K hours, but the low ability workers are not. So here's what's going to happen. All the high ability workers are going to work. None of the low ability workers are going to work. And so I've separated them out. So what I get is, again, the information is no longer hidden. I know who's high ability, those who chose to take the job, and I know who's low ability, those who chose not to take the job. All right, so this simple foray into hidden action and information gives us sort of a starting point for thinking about institutions and incentives. So how we can write down sets of actions, payoffs from those actions, to induce right levels of effort, and also to separate out who's of one type, who's of another type. What we're going to do next is look at auctions and see how we can write down different institutional structures, and those create different incentives for people to take different behaviors, and how those different institutional structures affect the outcomes. In some cases, they'll have big effects on the outcomes. In other cases, they'll have no effect. All right. Thank you.